Welcome to this Frequency Matters podcast. I'm Pat Hindle, and I'm here with my co-host Eric Higham, along with a special guest, Telemaco Melia, GM at Echostar Mobile. Welcome, Telemaco.
Hello, everybody. Thank you for hosting me today.
So Echostar Mobile recently announced a strategic partnership with Murata and KYOCERA AVX to bring highly effective and unique satellite IoT connectivity solution to the European and North American markets. So I wanted to really learn more about this partnership and some of the design aspects of the IoT ecosystem. So first, maybe you could tell us about the IoT satellite connectivity options. You know, what type of networks and connectivity vehicles are available since there's so many for IoT applications?
Yeah, so the work that we've been doing for the past few years has been trying to understand how to complement existing terrestrial networks with the satellite connectivity option. The goal has always been to complement existing deployments and trying to understand what are the pain points that customers have when they need to deploy IoT solutions. So the work that we started now 4 years back and announced commercial availability at the end of 2022 was really directed to an existing ecosystem of IoT devices that would greatly benefit from having 100% coverage. Because at the end of the day, IoT is a service where you need to have continuity independently of whether you are in a building in a city or in remote regions. So the goal has been really how can I bring connectivity to 100% of the sensors and enable what we call smart country, essentially giving, we've been digitalizing buildings, digitalizing smart cities. What is missing is digitalizing the entire nation or continent. Reasons to do that are very obvious and under the eyes of everybody every day. Environmental changes that you need to monitor, infrastructure that you need to monitor, whether these are natural hazards or human intervention. And the only way where you can do it efficiently is to use satellite. That's why we started to work on these solutions. And today we are building an ecosystem of devices, chipset manufacturers, device manufacturers, antennas manufacturers that are intended to ease the work of system integrators and OEMs that are looking for satellite solution. Because if it is easy to integrate and it's cheap to use, then people will adopt it. Otherwise, you will always encounter barriers. The announcement with Murata that you announced at the beginning of the discussion goes exactly in that direction. Murata had a transceiver that was working on S-band, so the 2.1 gigahertz MSS spectrum. We tested the device both in Europe and US, and we concluded that with the existing hardware and specific circular polarized antennas that IVX is proposing, then you can close the link with satellite at a very low cost and is very cost efficient. So that's the intention. Bring to the market things that people already know, then how to integrate, and then it's so easy and so cheap that is a no-brainer to include satellite from the beginning of any deployment option.
You mentioned IoT a moment ago, and if we focus on that, what IoT applications can benefit from satellite connectivity and why?
Today, we see adoption from fields like environmental monitoring, so meaning rivers, oceans, waters, land, anything that has an impact on our daily life. Witnessing floods that have been creating damages for hundreds of thousands or millions of euros. Forestry is another aspect where, if you did see anything that was happening around Los Angeles in the past weeks, this is that has a lot of impact on even lives, not only assets. Being capable of detecting these kind of events at the early stage is actually what makes you very efficient in the implementing countermeasures in due time, before it's too late. So forestry management, anything that is precision farming. We do have customers today deploying sensors in the middle of North Scotland to monitor moisture and temperature in various sides of the fields. there you have funny side effects like cows crunching the device, but that's the type of applications that we see happening. Anything that is around tracking, whether we talk about assets, people, or livestock, there is an emerging need in track this type of asset across land and sea. Effectively, we also had recently a webinar hosted by Beecham Research on this specific topic. So tracking is a strong application, and the Murata announcement goes in that direction, because with a chipset that is very compact and low cost, you can enable uplink real-time applications, which are often all you need to have an effective tracking service. Anything that is monitoring utilities and critical infrastructure, there is a need to have specialized devices that can be deployed in the field without the need of terrestrial networks. Anything that is long and skinny, like pipelines, roads, rails, can be potentially covered by the terrestrial networks, but often this is not very attractive commercially. So having satellite as an option to deploy a solution becomes very handy, because you just need to stick the sensor and then you're good to go.
And so can you tell us the advantages of a LoRa wide area network satellite technology compared to the alternatives, since that's what you're using here?
Yeah, so when we started our journey, obviously we needed to understand what modulation and what chipsets we should be using. At that time, 3GPP release 17 was not yet available, and the investment to modify existing NB-IoT chip would have been dramatically high. So at that time, we needed to choose a technology that was ready, and was more important, was with an existing ecosystem of devices. NB-IoT has been growing a lot, pushed by the Chinese market, and effectively it has been sponsored, primarily in China. But when you look at, where do I find a device with NB-IoT capabilities, you do find them, but the choice is not great. Whereas if you go on the LoRa side, you do have a great choice of available sensors. So for us, the technology was, we need to pick something that, today is flexible enough to work off the shelf, and at the same time, something that has an ecosystem around. And when we tested LoRa, we didn't need to modify the center chipset. It would work off the shelf. We just required a few software upgrades, which obviously saves you a lot of money at the beginning of a journey that you don't know how successful will be. At the end of the day, IoT is a very fragmented market. It's a global market, but it depends on the application. So you can be very successful as you can be very unsuccessful. So we had to take a bet on what was enabling us at the lowest possible cost. There is also a technological aspect. In LoRaWAN is a technology that works below the noise floor. So these combined with our large geostationary satellite was giving us a strong link budget. And if you have a strong link budget, it means that the device footprint can be small, the antennas can be small, and then the power consumption is also reduced, which makes a satellite device pretty similar to what people are used to seeing in the terrestrial world. And coming along with a small footprint device that could, there is a premium, but could be comparable to what you see on the terrestrial side, then obviously you are eliminating one of the barriers, which is complexity and cost of integration.
If we dig a bit more into the architecture and the technology, can you tell us about Echostar Mobile's carrier-grade S-band connectivity and its original development?
Yeah, so Echostar Mobile operates in Europe an S-band service. So we own our own satellite, Echostar 21, and the service is carried over S-band license frequencies to the 1 gigahertz. So the fact that we have licensed spectrum enables immediately a set of use cases, because we are not sharing spectrum, and then you can go after things like critical infrastructure, sensitive applications that otherwise would be impacted by interference or other shared access spectrum policies. So For us, obviously, the S-band is an asset because it provides a carrier-grade type of service. And then what we did when we deployed the service was to have a setup that was very close to what you will see in the in the cellular world. So we do have a certain level of security for key management, thanks to what Semtech is offering as a cloud service. We have a secure element in the chipset itself, so that provides a root of trust, and then a series of features that otherwise wouldn't be available. And the fact that the network is managed by service operator, service provider, then it provides obviously all the advantages of managed network. So we wanted to take a step to make it really available as people will be used in the cellular world, and then to complement existing technologies and existing terrestrial deployment. So that's why our module that has been certified for operations by FCC and Europe is actually dual mode. So it means that you can connect to satellite, but you can also connect to an existing terrestrial network. And then for the user is totally transparent.
So most of our audience is RF engineers. So maybe you can tell us a little bit about the design and components, in this Type 2PT LoRa connectivity module.
Well, the Type 2PT is something that is built and commercialized by Murata. So I'm not in the position to give away details on the chipset itself, but it's all the tests we did were based on the on the header model 2GT that was supporting S-band, and then they decided to commercialize it as this new part number. People that are used to work with the Murata 2GT modem, they will find absolutely the same capability. So to actually being able to broadcast, transmit in the S-band, we just had to make sure that we had enough output power at the modem. That's what we've been testing, and we managed to successfully close the link with our satellite because it's geostationary and because it has large antennas. We have 18 meters antenna in the sky, so that makes it's like having big ears. You can really listen carefully what's going on. So the work that was really done was essentially to be able to have a good transmitting power, and that's why we also work with AVX to have a circular polarized antennas that could increase the link budget to transmit to the satellite. So the 2PT, the announcement that you saw, is really uplink only communications. So is the sensor sending uplink messages. That's one of, if you want, of the differences that you have with the cellular NB-IoT protocol, where NB-IoT is primarily, you need to be connected before you can send. So you have an handshake at NAS level. In this case, LoRa, you can wake up, send a message, and go back to sleep. And then the message will be received by one or multiple gateways, depending on what you have around you. But you don't need to establish a connection before talking. That's why LoRa becomes very power efficient. So we did the same over satellite, and from a transmitting standpoint, there is no difference from what you would see on terrestrial.
So clearly, this is an ongoing development and evolution. What improvements have been made in the newest generation compared to the previous one?
So we are always talking about the 2PT modem, or we are talking about what EML commercializes as the AM2050?
Either.
So the Murata this is something that you need to go back to Murata and ask them exactly changes, but the 2PT has been promoted really for satellite operations in the S-band, whether this is Echostar or another operator. So MSS spectrum is available worldwide, so there are other players in the space, and this is really implementing a subset of the functionalities that we do have available on the EM2050. The EM2050 is the modem that Echostar Mobile commercializes in Europe and US for bidirectional real-time communications. So you should see Murata as a simpler version that implements uplink-only communications. There are a number of applications where having bidirectional communications is not necessary. You can think, for instance, about tracking or reporting periodical information about temperature or humidity or other type of sensor. You may not need to actually have a downlink to talk to the sensor. You just need to receive the information once or twice a day. In that case, implementing the 2PT is probably sufficient. But there are other applications like critical infrastructure or other things where you do need to send information back to the sensor. And in that case, you will need downlink. So our modem, the EM2050, actually provides bidirectional communication. So you are able to join the network as you would join the network in a terrestrial deployment. And then once you join the network, you can actually send and receive data. There are use cases where, for instance, you do need to have, for security reasons, updates, firmware over-the-air updates. So FWOTA should be available. We do provide multicast, and then there are a number of other enhancements that we can provide with respect to, adapt ADR algorithms for power efficiency, fast link channels, and this type of thing. So the EM2050 is like the Rolls Royce, if you want, and then the 2PT is the small Cinquecento that gets you where you need to go at a lower price point. It all depends on the applications at the end of the day that people need to deploy.
And the other partner in this was KYOCERA AVX for the antenna. Is there anything unique about that antenna that enabled the solution? Is that like a chip antenna?
So with AVX, we have been working on different solutions that obviously have a different price point. For our core business, we have been working in the past already with AVX for the MSS terminals, the big gun type of terminals, where we had to implement a quadrifilar antenna, circular polarized, which is obviously very good for these terminals, but is too expensive for an IoT object. So for IoT, we had to understand what can we do to actually, increase the link budget, but maintaining cost low. So the first thing that we did was effectively using these cheap antennas, and that you can also find on our website. These are linearly polarized antennas, and we use two, one for TX, one for RX. We do that because the S-band FDD has an interspacing of 190 MHz, so you need to be able to filter out. So we use the antennas as natural filters at the end of the day. But these are linearly polarized, so you have zero gain. And then, although it's linearly polarized in omnidirectional antenna, you might encounter problems with interference. So we said, okay, let's think about a mid-level antenna where you actually increase the gain. It's a bit more expensive, but it would make sense for other applications. So that's why we work on these patch antennas that are circularly polarized, and they do provide 3 dB, I believe, gain, or 4 dB gain, and then can be used to increase the link margin while avoiding, for instance, the integration of a power amplifier, as in the case of the Murata 2PT. I think antennas are often underestimated by people integrating. We have been seeing cases where people were claiming that a simple firmware upgrade will make a terrestrial chip also working on satellite. That is wrong, because you need to be able to have the proper antennas working on the proper frequencies if you want to actually have the link budget, the favorable link budget. So AVX has been very receptive on the things that we needed to test, and I think they are also involved in other projects where they are combining also L-band and S-band for all the work that is currently going on this direct-to-device market, bringing satellite directly to handsets for MSS spectrum. So at this point in time, KYOCERA represents a strong partner because they do have expertise in the field, and they are actually investing in bringing low-cost solutions to that respect.
You talked a lot about the technology. What type of growth are you expecting in these satellite IoT markets over the next 5 years?
Look, the satellite IoT market is a global market with a variety of applications worldwide. I can tell you that over the past couple of years, we have been receiving constantly inquiries from regions where, unfortunately, today we don't have yet coverage. There is a huge market in terms of cattle tracking in South America between Brazil, Argentina. We are talking about several millions of cows that need to be tracked, and they need to track the cow from the birth to the moment where it is killed. So I don't know the proper English term, but because of traceability. They need to be able to trace the animal to be able to sell it to specific markets. Like Europe is demanding tracking of the animal, and that means a lot of money. Okay, so this is one big market that we see growing. There is a huge market in South Asia for anything that is palm oil. Monitoring the palms, the trees, to be able to collect the oil at the right point in time seems to be trivial, but today they use very expensive means, and then having satellite sensors would simplify a lot their operations. And again, is a multi-billion market. We constantly receive inquiries for tracking different assets, across the globe. Some of the assets are not something that we would really do, but there is a need for tracking anything, and that's why we have been pushing the Murata thing, because that gives you a very attractive solution to be able to include this type of trackers almost everywhere. In terms of regions, Middle East is one of the regions with a high number of IoT projects. There are a lot of projects going on there. We've been contacted several times, to provide solutions also in that respect. Unfortunately, there are places where we don't have yet coverage, but we see a growing demand worldwide. It's difficult to give you a number, and that would be in any case wrong. But I can tell you that there are, all the applications we've been working on. We see a lot of potentials in these projects. There will be additional applications where, if we change the way satellite is perceived, then it will be even greater. Satellite is often perceived as the gap filler to lack of coverage, but if this is integrated at the right price point, then it can be used as just an alternative technology to send data to what is already available, and that is the game changer, in my opinion. That's why we are pushing a lot to make satellite connectivity so cost effective and so easy to integrate. Then at this point in time, people will not even think if they need to put satellite. They will just do it by default and then use it when needed, whether this is lack of coverage or whether this is safety, security, because they need to have a backup connection.
And I always like to wrap up with, what kind of future developments do you see on the system and component level in the future?
There are some developments that have been done, but I think they didn't capitalize yet on the investment. On the LoRa side, there is the possibility to deploy what they call relays. Relays are essential physical relays that take signal from one side of the room, and they move it to the other side of the room. At the beginning, the LoRa Alliance has been working on terrestrial relays. What we did was implement one of the first satellite relays. It means that you can turn any terrestrial object into satellite without changing the object itself. So there are things happening in there that will be game changers, because then with a battery operated device, you can retrofit any existing deployment to actually provide coverage where you don't have coverage, or to connect objects that otherwise will be too expensive. So these things have been done, but have not, the mass market adoption is not there. So that's one thing that we are pushing strongly, and it's something that in the cellular world doesn't exist, because you cannot today deploy a physical relay. Just to make a comparison, people may remember small cells that people will deploy at home as connected to the DSL to provide a local coverage. That's basically the same thing, but much cheaper and battery operated. So you don't need any type of existing backhaul connection. So that's an interesting development, and then integration of satellite and terrestrial, and convergence between satellite and terrestrial will be one other key aspect, in the sense that people, with all the, if I take the promise, for instance, the 5G new radio, the Red Cap, and the Evolver Red Cap, which is essentially technology to provide IoT connectivity with 3GPP, when these modems will provide seamlessly terrestrial satellite coverage, then people will just use it because is available. Today, that's not yet reality. You have different hardware for different connections you need to manage. Yes, we do see the first mobile phones implementing in IoT, but still there are two different things managed at application level. So that convergence, when will happen really, then at the cost-effective price point, then it will be something very interesting that will open a lot of applications that today are not yet there simply because it's too expensive.
Excellent. And thank you, Telemaco, for giving us these insights about IoT networks and applications, plus Echostar's solutions in this area today. This has been great. And to our audience, please give us a like. And you can find more podcasts at podcast.microwavejournal.com. And thanks for listening.